So in this video I'm going to cover off how to search using database objects and also filtering, how that works with collections. So I've sort of alluded to this in the orders and order details. With the order details, there is a filter that's set up based on the order. Now this can actually also be done as an override, just overriding a subset. It's exactly the same. And in fact, this is actually just getting the attribute value and returning the value, so returning the conditions. So this is basically, these conditions are used essentially as the where clause. So whenever you access this collection, it always applies these filters. Whether you're deleting something, it would only delete things within this subset. If you're doing a count or enumerating through it or getting an item, it always applies this filter. So this is that's sort of essentially how it works. So what I wanted to show just quickly is we have a products collection, but in our Northwind model we also had active products. So what I want to do is this is how I would actually set this up. Would be to have two classes. One would be the products, which is everything in the table, and then have an active products, which is the discontinued is false. So I'll show you how that works. So essentially we can just copy this class, create a new class called active products, which inherits from products and just overwrites the subset. So we're going to copy that. So chuck that in there. And so we do need to pass in the Northwind model. Okay. So the beauty of this is that essentially whenever we access this active products collection, it's always going to apply this subset. Okay, so I'll just, if we go back to our products and we remove this is going to always return everything in this table. Let me just clean this up a bit. Okay, so let's just set this up properly. So I would in here typically have the products, and you would use that, I guess, for adding or deleting things perhaps, and probably you just want to use the active products to enumerate through, but you can do both in, all those operations in each collection. So okay, so now we've got essentially two collections that we can use. So let's just prove that out by writing what's in the actual list and looking at the SQL. So if we look at the products count, run that. It's an issue. I didn't set the products somehow. My bad. Try again. Okay, so we can see here that it is applying this filter for the second one, which, okay, not rocket science, but it's a useful feature, and I'll show you why. Because if in the products collection I apply a search, so this is the second aspect to it. So there's the filtering, which you always apply to the collection, but then there's searching, which will search within that filter. Okay, so if I wanted to do a search by, say search by name, and I can put, this would probably be something that the user would enter, and we can use some wildcards to actually filter it down. So to do that, we can use base.objects search. And we can just pass the condition. Now SQL conditions, I will go into SQL stuff a bit more, but conditions are essentially what will go into the where clause. There's also things you can do with it. You can do a lot of complicated expressions. It's all database agnostic. You can do parenthesize things and arithmetic operations. So what we want to do here though is just something simple where the name is like something, and we can put in % to look for anything before and after. So anything that's going to contain name filter will be returned. The other thing I need to do here, of course, is actually return the results, which would be useful. And that can just be a list or an array of products. Okay, so let's actually run this. So rather than, what can we do? We can enumerate them, I guess. Products search by name. Anything that's got A in it, we want to write them out. And similarly, we can do that for active products too. So the beauty of this is that the search by name will be there, but it will actually only be filtered by name. So yeah, this object search will actually be within that filter specified for this class. But at the active products level, that would be searching for everything with A in it, but we discontinued is false. So let's just run that. Okay, I forgot to do something. Okay, got a bad filter. I think I did a filter on something. Actually, this brings up a good point. In the database, look at the database, look at the product table. Now, it's product name. So I did that wrong. But the interesting thing about this is that typically if you don't have, see, these product classes, because they're using the early binding, it's actually creating table joins to all those other things which you just saw in there with the inner joins. But if it wasn't doing that, you can only ever really search by what would be in this table. So sometimes that's not enough, you need to do a lot more, and you can do that, but you sort of need to bypass this a little bit. So it depends at what level you want to, how complicated it is. But for something simple, this will work. But if you want to do something more complicated, like, yeah, you want to look at different tables and that sort of stuff, I guess it is a little bit brittle to assume that for example, if you wanted to filter by category, find all the products in a particular category, for example, you could do that with a condition here because we are joining to those tables, but that's a little bit brittle because you're assuming that this is here. I personally don't like that. It's not clear what you're doing, but you could. It's up to you, I guess. Anyway, so if we try that again, quite a few, we might just change that down a bit. Change the filter, just say AN, AB. So we haven't got so many. Okay, so yeah, we can see here where the product names like AB, whatever. But this one here, we can see where discontinued is 0 and we're applying this condition here. And you'll note that it is in parentheses so that you don't have any sort of precedence issues. Okay, so I guess that's the beauty of that, is that you can, in a sense, reuse what's at the lower level. And if, for example, you know, in the products you've got something, you had a deleted flag, for example, where you never ever really want to see those products ever again, then you can just apply it here, and that will naturally filter up to the active products and the searching, etc. So I like that because a lot of the other object relational mapping tools don't do that. You sort of, it doesn't, that sort of logic can be dispersed, and I just like it. I like how it's can be consolidated like that. Anyway, what I'm going to show now, so that's some simple searching. What I'm going to show now is that you can do some more advanced searching. What I'm going to do probably actually is just disable some of these table joins so that we can assume that they're not there. So for the product, I'm going to turn that off. This will still keep working, of course. It just means that it will actually load it when we actually call category or we call supplier property, so this will still work. Nothing we need to change there, which is nice. What I'm going to do is go back to products. Okay, so what I'm going to do now is something a little bit more complicated. I'm going to do some table joins explicitly. I'm going to join the product table with the category table. I'm going to search for, maybe we're going to list all the products that have a category name of produce, for example. So let's go back and I'll show you how this is done at a lower level, and essentially that you can create a SQL statement in a database agnostic way, which I think is really powerful. You can, this will run against SQL, MySQL, SQLite, Access. There's a few others, I think, and you can generate this SQL statement and essentially then push that data or that data reader into some objects. So you can really go low level with this. There's no limitations there. I think sometimes you do need to write SQL, and SQL is the most obvious way of doing it. And so there's no limitations in that sense. Okay, so let's do that. So essentially we're going to write a SQL statement, and we want to return all the products which has a category name. So we know what the category name is. So there are a whole heap of SQL statements, SQL expressions that you can use. You can delete, insert, and all of these are actually used internally for the standard object mapping, routines, etc. But it also has these other statements that you can use to, for example, create tables, create indexes, create views, use transactions, complicated search. You can group by, all that sort of stuff. Pretty stock standard stuff. So what I'm going to do here, we want to select add a table. Table name is products. Let's just double check that. And we've got another table. Let's call it table, and we've got another table called category. Categories. Okay. And we want to essentially join these two together. And we probably, because we're joining the tables, we can actually use that to preload the category object. But I'll probably do that as a secondary step. So first step, even though we're going to linking that category table, we're just going to load the products and get the return those results. So we've got two tables. We want to add a condition. So we have that field name there, so we can category name is equal to category name. And we want to join these two tables together as well. So we want to join, so we need to do joins tables.joins, add a join. Left table is products, join type, we're just doing an inner join, and the right table is categories. Let's just put that on a different line so we can read that. So to join, and we want to so this would be the on section of the inner join. So where do I add? I believe they're the same field names. Have a look. So category ID in the categories, and in here we've got category ID 2. Okay, so foreign key. So we're essentially joining them together. That's creating our inner join here. And now we can use fields from either. Okay, so the next step is really to just create a connection. So when I use a using statement, connection equals new connection scope. So this is essentially opening a connection to the database. Okay, so we can just do an execute. We can do execute, non-scalar, non-query, etc. So you want to do is just normal execute, get the result, create a reader, and pass through the select statement that we've got. And want to read through the results. So read through that stuff. Create a list here of our results. Product. And return that at the end. Okay. So there are a few functions that we can use that will load an object or create a new object from a reader. So I think there's in database there is a object from data reader. So this will use the current row, but we do need to specify the collection, which is just this collection. The reason we need to pass the collection is that in a products it needs to be able to instantiate one, and the collection class can do that. It actually has an item instance function, and by default it determines that from this, but you can override it. So if you want to do polymorphic sort of stuff, you can override that item instance, but by default it's going to create this product for us and automatically call this constructor. It's always assuming that there's a constructor with one argument for the actual parent. Anyway, so that's why we need to pass the collection, and then we just pass in the reader, and voila, we have a new object. So add that to our list, and that's it. So now we're a lot more low level, but we have full control over what we need to do. And I just need to cast that up, I think. Okay, so let's go back to the program. Model.products search by name. Okay, so we're searching by category name. I think there was a category called product or produce. Got bad memory. So let's have a look at all the products for produce. So just enumerate through these ones. See how that goes. Oh, I did something wrong. What a surprise. Okay, so we're selecting stuff from products, inner join categories on products or categories, where category name is produce, and I cannot spell category name. Let's try again. Alright, great. So yeah, like I said, we're joining the tables. Category name is produce, looks good. Now, you will note that if we actually pull down the category, it will load them lazily because we haven't got the early binding on there. So if we do category.name, just to verify that what we're doing, we will see a whole bunch of SQL statements as well, because we're not loading that category when we're from this main table, this join table. So what we can do, we can actually leverage that. It seems silly not to leverage it considering we're loading it right there. So what we can do, even though we don't have on here the early binding, we can do that by hand. Like, we can just assign that by hand. So let's do that in here. So we'll create our product object and get a handle on that. Now we should be able to assign a category, and that's in here. Now we should be able to instantiate one from there as well. We know it's going to be a category. It's from the database, from the reader. Again, we need to pass the collection. So we don't have this here, but we do have that at the root level. So we can get, just go to the next line, so we can get the root container. That's a Northwind model. Categories. So we have our collection and we pass through the reader. And that will handle all that magic for us automatically. It's read only at the moment. You probably would want to set the category when you're creating a new one. So category reference, object is new value. Okay, so let's see how that goes. Great, so now we're loading up all those categories for us. the point here is that we've got control. We can do whatever we want, but we can still hook into what we have. We can still hook into these objects and map that. So that's all I really wanted to show. Hopefully that's been useful.